So this is one of my projects that I did, and it was pretty exciting for me to go ahead and complete this project. So this is basically a project in which I'm recognizing different hand features, and based on that, I'm doing some filtering out of different features from the image, and based on that, I'm displaying certain emojis. So this is most of a kind of a demo that I did, and I posted on LinkedIn and on open source. So a lot of people like that. So tonight I'm just going to tell you guys briefly how I did that. All right. So let me just quickly turn to this Python notebook. Okay. And in the meantime, if you guys have any question, keep posting them to get back to you and answer as many questions as possible. Right. So this is more of a hands-on session in which I'll be mostly referring to the code that I've already used, and I'll try to explain each of the lines that I'm writing and how can you optimize that. So, and also this is one of the more basic implementations that I do. So you're most welcome to make some changes, maybe enhance these projects, and then maybe raise a pull request to my repository, and I'll be more than happy to add those and give you the credit for that. So that's my open source. Okay, so let's get started. So first, in
Akshay,
in
Akshay,
this
can you hear
project
me?
we have three parts. So first is we have to create our own data set.
Akshay, hey
Okay.
Akshay, do you there? Hey Akshay,
So
It's
you
lagging a lot.
realize,
hey Akshay,
Akshay,
yeah,
can you turn
I
off
can.
your video? Uh,
Yeah, hi.
hey Akshay.
Turn
Hello.
off your video.
Can you hear me?
Turn off your video. Can you hear me, Mahesh?
Yeah, I can hear you. Can you hear me?
Yeah.
Yeah.
Sorry, guys.
So,
I think Akshay is completely
so
frozen. This always happens when you're doing things live. Yes. Wait for a second. Okay, so Akshay is nowhere around.
hey
Oh,
Akshay, you there?
he's joined again.
Yeah, sorry about that.
Akshay, can you please okay, turn off your video. Okay, great.
Yeah, okay, sorry about that. Wait, let me go. So
Okay,
can you
speak,
hear me now?
speak. Yeah, I can see. We can see. I think this is frozen in others people's in the other session screen.
Okay,
Can you click share screen again?
I just did. I just shared my screen again. Can you see me writing on the screen?
N- No. So, Akshay, can you close it and join back again?
Okay, let me do that.
Yeah.
Yeah.
Sorry about this.
Yes. Okay. For in the meantime, someone just asked if we will if you will receive a recording for this, and yes, this is being recorded, and this is going to be in the DeepCognition web page. If you go there right now, you can go to the resources web page, and then you can go to the webinars, and you'll see that.
Okay. Now I think Akshay is back. Akshay, can you hear us?
Yeah, I can.
Okay. Yeah, you can please go ahead and share the screen.
Okay. Yeah. Can you see it now?
Yeah, we can do.
All right. Yeah. So
All
let's
right,
get
cool.
back. Okay. Yeah. So in this, as I told you, in this project, we'll be working mostly on three parts of the application. So the first part is that in which we have to create our own gestures, because it's actually pretty difficult for you to get these kind of features on the internet. So I tried exploring a lot of different data sets that I could use, but then it was pretty difficult for me to actually get all these different information that I wanted to. So what you could do is just use your own filters and create your own data set. So let me just start by how I did that. Okay, so this is mostly I'll be using my old project, and I'll be trying to explain what exactly I am doing in this. So this is all the basic functionalities on the basic libraries that I'll be using. So first is of course computer vision, NumPy, and OS. OS is basically for creating folders. Okay, so then I'm now declaring several some sort of these are the local variables. That is the image size, the height, and the width of the image. Okay, so all right, and so then I have a small function which is this one. So what this does is that you create a folder. So if the folder part does not exist, create it and make a directory. So everything looks pretty fine now. All right. Okay. So yeah. So let's get down to some business. So yeah, so this is actually the main function that I'll be running. So this is called store images. I'm defining the total number of pictures as 1200. So for each gesture, I'll be roughly creating around 1200 images of that gesture, and then I'll store it in specific folders. Okay, so this is where I open the image. I mean, open the webcam, and then I create a folder inside of my gestures folder, and then I see uh, the ID from this input that I'm getting. So we'll talk about that later. And so these are some variables that are mostly flag variables that we'll be using to make sure that we stop when 1200 images are captured. Okay, so yeah, so this is actually the next part of the code. Okay, so yeah, so this is a bit tricky to understand, but not very tricky, but then I'll just go briefly through this one. Okay, so what I'm doing is I am just running through a loop, and then I'm reading the frame from the webcam that I've opened. And then if you know that the images are flipped, so the images are mirrored when you read through a webcam. So I'm just flipping them so that I get the actual image. And then what is happening is that this is my first kind of, you can say, HSV filter, and I'm converting the image from color, that is BGR, blue, green, and red format, into HSV format. So HSV is hue. Is a different color format. It's mostly it kind of helps you to get different depth effects in the image. So you can go through that, and it is very effective if you want to get images at a different depth in the same frame. So I've taken a HSV format of the entire webcam feed, and then what I'm doing in this one, this I'm creating a mask. So what I'm doing is that I'm taking going for in range operation. So what in range does is that you select certain amount of so image, the colors in the image are in BGR format, that is in the blue, green, and red range. So this range, if you can see here, this is the approximate color range of your hand. So this will be somewhere around the brown color, right? So I'm taking an in range. So I'm doing what, I'm creating a mask from HSV, and I'm doing an in range operation for this color form, this color range. So what it means is that I'm basically looking only for the skin color inside the frame. And then in the next step, what I'm doing is I'm taking the bitwise and of the actual image and the mask that I created. Okay. So what this does is that it filters out only the color in this range. That is only the skin color. So whenever you do that, you only filter out only color of your hand from the image. So it is very easy for this filter to get the all the hand gestures that you want, and later on you can always use a different approach to that. You can even use contour approach, or go for different approaches to that. But this was pretty basic for me, and hence I decided to go ahead with that. You can always have a different implementation. Maybe you will have a better accuracy with this. Now what I'm doing is I'm converting this image. So this is basically color image. I'm converting it to gray, that is a black and white image. Okay, then what I'm doing is I'm doing a Gaussian blur. So what Gaussian blur does is that it kind of smoothens the edges and gives it a blur effect, and it really helps when it comes to when you want to smoothen the image and do further pre-processing. Okay, so yeah, and then after that, I'm doing some dilation. So dilation is mostly for image pre-processing. If you want to know more about this, you can always read the OpenCV documentation. And then I'm doing a morphology X, which means that I'm further simplifying the image for the computer to easily understand and easily detect different features from that. So after that, what I'm trying to do is that I'm trying to find the contours. Okay. So what contours does is that given the image, it tries to find different physical features. So let's say if I have an image and if I have a hand in the image, then that means he will be able to find contours, that some lines or some borders to that hand. And what I'm trying to do is I'm trying to find all the contours. So let's say if even if my image has certain other object that is of the same skin color, maybe I'll have some part of my the other hand as well in the image. So what I'm trying to do is I'm trying to find all those contours that are in the skin color range, and then I'm going to check for the maximum contours. I mean, the maximum area that the contours cover. I'm going to pick that contour. So obviously that will be my subject. That is my hand gesture that I'm trying to recognize. And what I'm trying to do is that I'm trying to find out that this contour area, it should be greater than 10,000, so that maybe let's say if certain small object comes into this in front of the webcam, that is obviously some noise, and I don't want to treat that as an test subject. So I'm going for some threshold value that beyond that, only beyond that I'm taking gestures. And other than that, if there's some value, then that means it is mostly noise that we have to which we have to neglect. Okay, and then what I'm trying to do is I'm finding a rectangle around the image. That is, I'm getting the x, y, w, h, the starting point, the height, and then the width, and the starting x, y, and then the width and the height of the image. And then I'm taking. So then what I'm trying to do is I'm only trying to get that part of the image into the save image format. Let me just get rid of that. So this is both basically more sort of pre-processing in which you can neglect that. It doesn't make much of a difference. And then what I'm trying to do is that now this image that I've captured from the threshold, I'm trying to resize that into image X and image Y. So if you see clearly, the image X and image Y is something that I've already fixed. So it is 50 by 50. Okay, so I'm doing that. Yeah. So now the save image will have, after this particular operation, the save image will be of size 50 by 50. And then what I'm trying to do is that I am putting some text on the screen stating that, the capturing of the image has started. And then I'm writing that image into the gestures folder with the pick number, which keeps on increasing after each iteration. So if you can see, it keeps iterating after each capture, and then I'm adding .jpg at the end, and then I'm saving the image. Okay, so this is the whole operation. And if you can see, the pick number is 0 here, and it's going to increase. Yeah, so it's increasing every iteration, and then it's going to capture all the hand gestures. Okay, so if we look clearly, if we look clearly, let me just show you another screen in which there are actual gestures present. Okay, so yeah. So basically what happens is that after you have, so what you do is that you run the script for once, and then you save the gestures for one hand feature, and then you go ahead and do for the second hand feature, then you go ahead and do for the third hand feature. So it depends on how exactly you want to proceed with that. Okay, and uh, if you want to see what I have done, so let me just show you that. Okay, so what I've done is I've created different hand gestures, I think around 10 or 12 of them, just so that, yeah. So if you can see my screen, I have around 12 gestures. And if you can see my desktop, I mean my folder, this is the hand gestures folder that I was mentioning. I've created already, right? So I have, if you can see, this is the first image. I mean, the first gesture that I'm referring to, the first gesture is just pointing upwards. So this, my index finger is pointing upwards. And what I've done is I've tried to, rotate it a bit, just so that uh, I don't overfit the data at the time of training. And then if you can see, different folders will have different gestures. So this is Samoan yo gesture. This is the rock gesture, and this is the fist gesture. So similarly, after that, you'll have these 12 gestures. Okay. So, and now what happens is that after this, there's this file called as create CSV. So it's an open source project. I mean, it's an open source project in which you just have to give the name of the root directory that I've given it as gestures, and it converts it into a train.csv file. So there are other approaches to do this as well. You can go for, let's say, you can even go for pickle, dumping it into pickle file, or maybe you can go for Swift storage. It depends on you. So I mostly prefer create CSV file, because at that time it gives me more, more flexibility into where I want to upload the file. So now this was the main, uh, the main part, as in creating the gestures part. And now comes the more interesting part. So what I did was, so since I was using my personal CPU, right, it had a lot of difficulties, as in when I had to train the model, because mine is a pretty old laptop. But then I came across this deep learning studio uh, by DeepCognition, and this actually has a very good, very good user interface. So I created my own project. Okay. So first, what you need to do is you need to go to create your own profile, go to a dataset section. You need to upload your own. So I've done that. I've uploaded my own gestures. So if you want to see how it is done, it's very easy. You just have to give that gestures file. So let me just show it to you. So this is the gestures file that I uploaded. Okay, so this contains the gestures, right? And then this is a CSV file that I had to upload. So this CSV file, it contains all the names of the images. It's very easy to do. And then after that, it contains the gesture, that is the label value that is associated to it. So there's a specific video on this DeepCognition.ai that you could go and have a look at that. So yeah, so it takes a bit of time, I think 5-10 minutes just to upload this gestures file. And then after that, you need to create your own project. So I just did that, and I'm just going to show how exactly we're working on it. So yeah, I'm going to open this project. So this is my Akshay Emojinator project. And as you can see, I've uploaded this is my private data set, as in it's not public. And you can see I have total of 14,400 records. That means I have 12 gestures each, and 1200 gestures, 12 gestures at 1200 images. So that gives a total of 14,400 images. Now what I'm trying to do is I'm splitting. So this happens, if you want to do it on your own, Python script, then it takes a lot of lines of code. You have to know a lot of different things on how exactly do you want to split that. But deep cognition gives you the flexibility to just choose a drop down menu. So maybe you want to go for 60 20 20. It depends on you, but I prefer 80 20. And then you go for one batch at a time, shuffle the data, and then you can even preview the image. I mean the data that is being that you are sending, right? So if you can see that this is my output, that is the gesture 8 corresponds to the thumbs up sign. And if you want to confirm, you just go there and open the gestures folder, see the 8th folder. This means that, yeah, what DeepCognition platform has inferred is correct, right? And then just a couple, I mean, just some things that you need to know is that first, this should be the input port, as in this is the input, the image is the input, and it is an image. There are other things that you could that you need to give as input. Maybe you have an array, right? Or maybe you are doing a categorical, that is creating one hot vector sort of that. So but we are doing an input as an image, and then the output I want as a categorical 12 12 vectors. I mean, the length of the number of rows in my vector it should be 12. So that means that I'm trying to classify between 12 different classes. So this is pretty easy, just with the click of a button. And then once this is done, you go to the model, right? Now this is where the interesting part comes, because so this is the UI, because up until then you have to code on your own, as in you have to make sure that you code each and every layer, and you need to make sure that you are doing everything correctly, as in initializing correctly. And then after that you need to make sure that your dimensions are matching. So it takes a lot of headache, because initially when you are just starting out, you want to see the model work, right? But then this is the beauty of it, because so if you can see on the left hand side, there are a couple of input layers. So let me just let me just delete all of this, right? If I can do that very quickly, and because I want to start from scratch. So yeah, let me just do this very quickly. Okay. So yeah, and this is very intuitive as well. So it gives you a lot of uh, signs. That means that whenever you are doing something wrong, it tells you that you are doing it wrong. You need to maybe change something. Okay. So I think we are done here. Let me just, yeah. So just this one layer was left. Okay. So let's start. What we need to do is first, go for the input layer. So what we'll do is we'll just drag and drop. It's as easy as that. Okay. So this is the input layer. I'm dragging, dropping it down, and then if you can see, it's inferring on its own that the shape of the image is 50 by 50. We didn't need to mention it. It does that on its own. I think that's the beauty of this platform. And this is the output, right? And so yeah, if you can see, since I've chosen a categorical 12, uh, one hot vector of 12 size, and so it's giving that the output should be of the length of the vector should be 12. Okay, so since it's an image, I want to go for some CNNs. Okay, so what CNN does is that basically it's very good for inferring when it comes to images, because what happens in images, you need to make sure that you are not only you are only getting those information that is actually related to the image. So you want to get the shape, the color, all these different things. So if you use any other model, maybe just a fully connected layer, or just a normal neural network, it might not be that effective. But when it comes to CNNs, each filter, so there are different filters in each layer of CNN, and each layer is responsible, and each filter in the layer is responsible for recognizing only one set of features. So let's say if I have a square image, right? So maybe one of the filters will be only recognizing the horizontal lines in the image, or the horizontal line in the square, and then another filter will be responsible for only recognizing the vertical lines in the image. So this is very easy for simple objects, but then when it comes to your hands or your face, you need to make sure that you have a lot of different filters, and each filter is able to learn on its own. So yeah, so let's go for convolutional model. So what you need to do is you need to just upload that. Yeah, so if you, as you can see, this is already here. You need to connect this. So it's simple drag and drop, right? And then if you want to code this convolution layer, it takes a lot of parameters. But if you can see on the right, the number of rows is 50 by 50, right? And then the number of filters are 32. No, so filter rows, I think I'll go for 5 by 5. So this is taking a kernel size, right? And once this is done, it gives you the image of 46 by 46. And what I will do is I'll choose an activation of, you can go for a lot of different activations. So I'll go for Relu. Relu is basically because it's very useful when it comes to learning different features. So you can choose a lot of different activation functions. I mostly prefer Relu or leaky Relu when it comes to because it helps in gradient descent. And then if you are actually very well versed in machine learning, you can even activate this advanced options, and then you can see the regularizer and other things that you need to take into care of. Okay, so what I will do is, so yeah, so if you want, you can change any of this. Maybe if you want to go for some same border. So what the same border does is that before and after, I think it should be the same. It should be, I did, yeah. So yeah, that happened. So I changed the border, as in earlier it was taking valid border. Now, since I've changed it to same, right? There is it. So yeah, I mean, after that, it is taking 50 by 50. So during convolutions, what happens is that your dimensions kind of get reduced because you are taking a kernel size of certain value and you are performing convolutions on your image. So yeah, so this happens, and then we will go for some pooling layers. Maybe we'll go for a max pooling. So what max pooling does is that it takes the max, the maximum value out of the convolutions, and it only uses that value to recognize different features. So why we do that is because in terms of when it comes to, so yeah, this is my, wait, yeah. So what happens is that we are only so in terms of images, whenever you see image, there's a lot of background noise, right? So what max filling does is that it only takes the maximum value, the maximum pixel value out of the image, and that means that is where our test subject is. The rest of the image is mostly background value, or maybe just background noise that we may or may not use. So when I do that, I connect this to a max pooling layer, right? And if you see, let me just zoom in. You can see the dimensions uh, kind of becomes by half. So what happens is that I'm taking a pool size of 2 by 2, and I'm only selecting the maximum one value out of two values. So I'm just dividing it my dimensions by 2. So this actually helps because you are earlier dealing with 2500 pixels, that is 50 by 50 pixels. Now after this, you have to deal only by 25 by 25 pixels. So it becomes very easy, and uh, the whole processing becomes very easy for your laptop. So let's do the same thing again, right? Let's go for another convolution layer. Yeah. So let me just drag and drop this. So I'm going to connect this max layer to convolution layer, and then I'm going to go for the same one as in 5 by 5 number of filters. Let me increase that to 64. So this filters is the number of filters that I'll be using for performing convolutions, and each filter, as you remember, is specific to only one type of feature. Okay. and then I'll go to advanced options, and I will go for the border mode as same. So this means that after the convolutions, the uh, the input and the output dimensions remain the same. You may go for other padding values as well. I prefer this one because it looks very neat. So then after this, I think this should be, I think it should be, yeah. So that took place. I think it's a bit of flag on my side. So, and then after this, I'll go for again a max pooling layer, right? So as you remember, this should half. I mean, the dimension should be divided by half, as in it should be 12. So yeah, that is correct. After this, what happens is that now I'll have 12, 12 by 12 images, and each image will have 64 filters, as in related to each image, we'll have 64 filters. So now if I flatten this image, what I'll get is I'll get a flattened, flattened feature vector of 64 into 12 into 12 features. So let me just do that. Let me flatten this. Okay. You can go for other, I mean, you can even go for one more layer of convolutions and pooling. But then I think that I should stop here because I don't want to overcomplicate the model. So when you flatten this one, if you calculate 64 into 12, you'll get 9216 features, right? And then what you want to do is you want to add a dense layer. So what dense does is that it's just a fully connected layer, just normal neural network with the number of with the output dimensions as, let's say, I go for 1024, and the activation I'm choosing as relu again. Okay, you can go for a lot of, there are bunch of different activation functions. Tan, which is good, and relu is great. Leaky relu, if you want to go ahead with that. So yeah, this is my dense. Now very important thing is that now we need to have some sort of regularizer. So yeah, so this is uh, my dropout section, in which what happens is that I'm going to connect this one to my dropout. Okay, so yeah, and then I choose a fraction to drop, right? So this means that when I'm performing my power propagation, I'll only be activating 60% of the 1024 dimension. So this is the my 1024 dimension feature. I'll be only activating zero point 0.6 of them, 60% of them, so that I don't overfit the data, or I don't use only one kind of neurons every time to learn. I need all the neurons to learn equally well, right? So hence we go for dropout. Okay, so I've done this dropout, and now I'll do is I'll go for another dense layer, right? So now what I'll do is I'll go for the number of output dimensions as 12, activation as softmax, and then I'm going to connect that to my output layer. Okay, and if this works, you can see a tick sign. So what I've done is that from 1024, I've directly joined those 1024 neurons to 12 neurons, and I've given an activation of softmax, which means that at the end of it, at the end of each power propagation, I'll get a value between for each let's say 12 feature vector, and I'm using a softmax regression. So softmax regression, what it does is that it's just an extension of sigmoid. So I'll be getting probability for each of those 12 classes. And so let's say if I get probability for the eighth value in the feature vector as the maximum, that means that I have chosen the eighth gesture from my image. So if you see the eighth gesture, this is the eighth gesture, the thumbs up sign. So this means that the image that was the input, after going through forward propagation, the value, I mean what I'm generating, is the hand thumbs up sign. So that is my prediction for that particular image. So after this, you can see that the model is ready. And also the fun part is that you can also view the code. So if you just click on view the code, and let me just zoom in on that, right? it uses keras. So if you can see, if you want to use that, into your own project or your Python files, you can see that, it is very well documented. What sort of convolutions are you using? What sort of math cooling layers are you using? Dropout, dense, everything is very well documented in this. Okay, so it's actually very nice. And then you can also go for Auto ML, which it automatically creates the model for you. But then I would want you to experiment on your own. And then we go for hyperparameters. Okay, so this is very important part. I think hyperparameters are very important. So you can collect the number of epochs, as in how many times the data set do you want to visit and work on and evaluate. So I've chosen it as 5 epochs, and then I'm doing a batch size of 64. That is, each time I'll take a batch of 64 out of my training set, and then I'll train on that, perform my forward propagation, perform my backward propagation, adjust the weights, and then go for the next batch. And then the loss function is categorical cross entropy. So this is basically a loss function for softmax regression. If you want to go for, let's say, sigmoid regression, in which the output value is either 0 or 1, you can go for binary cross entropy, which is basically used for sigmoid functions, as in sigmoid regression. And then I'm choosing the optimizer as Adam optimizer. You can choose from a bunch of different optimizers. You can go for error grid, error delta, RMS prop. It depends on you, but I usually choose Adam because I think it's easier to understand and it takes a lot of, it gives it a very good value. So yeah, and then you go for this epsilon and beta are something that are related to Adam optimizer. So when you read about Adam optimizer, you will get to know about what is beta and epsilon and beta 2. And then decay is basically the decay rate of beta, and then this is learning rate decay, in which after each step or maybe after each epoch you try to decrease the learning rate, just so that you don't want to overshoot your learning process. So this is something that, if when you get very comfortable with machine learning, you should try all these different different hyperparameters and just tune that, just so that you can get a more accurate model at the end. So now let's come to the training part. This is interesting. So yes, so what you could do is you can just click on this button. It will start your training, and you can get the loss, the amount of loss that is happening, the how much is your accuracy increasing, right? And it gives you a couple of bunch of different features that you need to take care of. All right. So if you want, so I'll just spin up one instance for you, right? So maybe I'll go for this one. Okay, so you have a lot of different features. You can even go for GPU training. And important, and one great thing about this deep learning studio is that it's also available on your desktop. So if you want to, just use it on the desktop, not on the web browser, you can do that, and it will make use of your local resources. As in, let's say if you're training on GPU, then it will make sure that you train on GPU. If you use CPU, to train on CPU, right? So yeah, and then after this, so let's just skip ahead. We can go for the results because I've already done this. So I've already tried and tested out a couple of times. So if you can see, I've done I think 8 times just to make sure that I arrive at the right results. So if you see this run 8, which I did a couple of days back, and if you can see, it takes I think a bit of time to get there. So yeah, okay. In the meantime, the the instance is up. So let's just continue and just start training. Then we can come back and see how our training worked. So yeah, so I think it will take some time too, because you can see it's starting training. It takes a bit of time because it's over the internet. So your internet should be fast enough to capture the results in real time. And so yeah, if you can see, if let me just switch back to the training, right? And if you can see, the loss will, if you can see, it starts decreasing over time, right? And the approximate time it takes about 12 minutes, and the accuracy is increasing around 80% at this time. I think it's pretty good just for the first epoch, right? So I've already done that. So I've already run this process, and if you can see the run 8, which I've stopped, which I did a couple of weeks back. So if you can see, the loss came to very small, I think in uh, very close to zero. And then if you can see the accuracy, it's almost, I think after several training instances, it goes to almost one, which is not a good sign, which means that I might have overtrained, but that's okay. We are trying to build a cube implementation. So this is for the training set. We want to check for the validation set. The loss slowly increases. The accuracy is around one, that is 100%, which is also not a good thing. But we were just trying to learn something, so this is okay in that case. So now this comes the interesting part, is that you can inference a lot of things. So if you have, let's say, some sort of the source where you want to check whether the model is working or not, you can just upload that, right? Or maybe you can just click on upload and upload your own test set, and start your inference, and you'll get some good results. And other than that, what you have is this is the great part, is that you can actually download the trained model, right? So once the trained model is downloaded, so let's download that and see how it looks. Okay. So yeah, I mean, I already downloaded that, so we'll have a look at that anyway. And then also we can deploy that on this instance only. So let's say we can have REST calls. Let's say if you are making a self-driving car and you want to make sure that you send the image and you get, so it's 36 MB. Let me just download that quickly, or maybe not, maybe, yeah, maybe let's go. I only have downloaded that, so we'll check that out in a couple of minutes. So if you want the, so I was talking about, let's say if you have a self-driving car and you want to, for each, let's say for every second, you are sending thousands of images to the remote network, I mean to the host, and then you get the inference from that. So it's actually very healthy to deploy your deploy your model on the cloud, and just use REST APIs to do your to maybe connect to the model and get your labels from that, or maybe get the inference from that. So this actually helps in that case. So but we are looking for downloading the trained model. All right, so if I go to my download section, my compress section, I already have downloaded that. If you can see, so yeah, so this is the interesting part. So we have a couple of different files in this. So this is the config.yaml file. So if you can see, it tells you a lot about the model that you are trained on. So let's say if you just send the model to somebody, you can actually see what kind of connections that you have used, right? So you have a conv layer, then your max layer, then flatten. So every, all the resources are very well documented, right? And then there are a bunch of different labels, and all these, uh, all the details that you would want. So yeah, and then after that you have this test.py file, which, let's say if you want to test something, you can just need to run this file, and it will be tested, and it will check the validity of the model, right? And but this is the interesting part. We are concerned with this. So let me just copy that to here, right? So this is my model.h5. Okay. So yeah, I will just copy that to here. You can see this is a model.h5 file. I've downloaded that last week. And so yeah, so this was the training. I think the training process was very easy. And if we can see, if we can go back, I think if we can go back to training, sorry. Yeah, so let's go back to the training tab and see how it's working. The loss, if you can see, it's slowly decreasing. The accuracy is increasing, and it's been just 2 epochs. That means our filter was very good. It is able to recognize different features very efficiently, right? And you can see a bunch of different records. So let's move back now. Okay, so this was that. Okay, so yeah, let me just, so yeah, so that was the create gesture one. Now what we want to do is we want to actually make our application, right? So for making our application, I'm going to use a couple of different things. Okay. So this is basically what I'll be using. Is first of course is OpenCV. Then I want to load the model, right? And then I'll use NumPy. This is my model. So since I'll be using the model file, that is the one I downloaded from Deep Learning Studio, I'll be using that, right? And let me just quickly run this. And so yeah, as you can see that it's using that TensorFlow in the backend. So that means that the dependencies have been resolved. And so this is, so first is this emojis or get emojis, right? So let me just first copy that. So these are the different functions that we'll be using. First is get emojis, right? So for each prediction, we want to overlay an image on the screen. So that was the main thing. So what I'm trying to do is I'm going to go to hand emo folder. That is this one, and it has all the different emojis. So let's say for when it comes to one, that was my finger up motion. I want to display this emoji. For eight, it was thumbs up, so I want to display this emoji. So I'm trying to do that. Think, okay, no problem. So yeah, and so this does that. It returns a list of the emojis that are stored. Okay, and then this is Keras predict and process image. Basically, what it does is that it gets the image that I want to predict on, and then it processes it according to my own size. So if you see that, if you remember correctly, that the image size and shape was 50 by 50. So whatever image I'm going to get, I'm going to convert that into 50 by 50, and then I'm resizing that, and then I'm converting into NP array and reshaping it into 50 by 50 by 1. That is why, because our model has been trained, Keras takes into 1 comma x comma y comma 1 or maybe 3. So if you are using a color channel BGR value, then this should be 3 because you have 3 channels. Because we are using black and white, I've chosen it as 1 value. And then what happens is that this is returned over here, and then I'm using model.predict. That means I'm predicting on the model, and then I'm returning the maximum probability and the class. So this is what we're concerned about, the class, whether it belongs to 1 or 2 or 3. So 1 is for this sign, 8 is for thumbs up sign. So yeah, and then also this is an interesting thing. mm, yeah, so this is also interesting. So what this is, it's basically an overlay. So what happens in overlay is that you want to overlay one image on top of the other. So there are a couple of ways to do that in OpenCV. So this part, it comes from add weighted. If you want to read about that, how overlaying, then you should read about this function. It overlays two images, right? But if you want to make it more effective, you need to blend them together. You need to uh, grab the planes and the alpha plane. This is actually some of the things that I had to read a lot about, and this code is actually taken from open source. So this part is taken from Stack Overflow. If you look for how to overlay one image on top of the other, in somewhere in the second or third link, you will find this piece of code, and it worked pretty great for me. I had to make a little of changes, so I did that, and after that, I think it worked pretty fine. So we'll be going ahead and using this function for overlaying, right? So if you can see, what it does is that it gets the emoji, it resizes it to some value, and then it calls this function blend transparent. And what it does is that it gets the image. So this is our base image, and I want to append emoji on top of that, or maybe just superimpose the emoji image on top of that. So I did that, I mean, using some sort of overlaying concept. So basically, you can grab the BRG plane from the image, you create a mask, right? You convert the mask from BGR to from gray to BGR again, And then these are some of the I'm doing added weighted. So if you see about added weighted, this is the face part, that this is the back part, and this is the overlay part, the emoji part that I'm trying to do, and I superimpose them. And so if you change these values, this is basically the opaqueness of the image. So if I change this value, if I turn it to 125 or something, so the emoji will be less opaque. So, but I think you need to try out with different values, whatever suits well for you. So this worked pretty well for me. So hence I decided to go ahead with this, right? And now comes the main part. So yeah, this is our main function. So first is we have the emojis. Okay, I'm doing get emojis. That means I'm getting all the emojis, that I'm returning a list of the emojis, if you can see clearly, right? And then I am capturing the video from the image, and I'm only, so what this does is that I'm only looking for this area in the screen, because I have chosen a region of interest. So if you can see, or if you want to just go ahead and write something, this is called as region of interest, which means we're only interested with this part of the image. That means, let's say, if I wanted to explain it in a better way, what I need, what I should do is that, let's say, if my image is this big, right, I'm only choosing the corner side, the lower right corner. So this is basically what I'm going to do, because I don't want to filter the entire image, because I know that my hand will be in certain area of the screen. So I'm just taking that as my a region of interest, and I'm performing my calculations there itself. So yeah, so if you can see, this part is basically the same as what we have done earlier, because that was our filter. That was the initial filter that we used to create our own gestures. So we'll be using the same filter to get the gesture in real time. And then after that, what we are doing, so we are doing almost the same thing, right? So up until now, we are taking bitwise, and this is my range of my colors, range of my skin color, and then I'm doing a couple of filtering, and then I'm finding contours, and then after that I'm resizing my image to 50 by 50, because I know that the image size should be 50 by 50. And then I'd use this, I call this keras predict function, which is here, keras predict. So it uh, it uh, takes the image from the input parameter. It passes on to keras process image. So that also does the same thing. It converts it 50 by 50, and then it reshapes it into -1 image x image y, 1, and then returns back, and I'm getting the probability and the class of my predictions. So what happens after that? I'm getting this predict class, right? So if you can see, I'm just printing them out just so that I know exactly what is happening, right? And then I call this overlay function. So this is the image, that is the base image, and then the emoji, right? So the emoji is basically, I have a list of emojis, and the predict class is the what you can say, the predict class is actually the is referring to the folder that I'm or the image, the emoji image number that I was saying. So let's say the predict class is somewhere around 2. That means that this emoji should be picked up, right? And so the overlay will be this, and then I'm passing a bunch of parameters. So this is basically x, y value. This in I mean at this value, or at this point, I want my emoji, and the height should be 90, the width should be 90 of the image. You can go for some, let's say, dynamic implementation. You can keep on increasing the size of the emoji or something like that. And then what I'm trying to do is I'm showing the frame, I'm showing the contours, and I'm showing yeah, and then I'm should yeah. So this should work fine. So yeah, if you can see, this is compiled and there are no errors, right? So yeah, I think this should be it. The only thing that we should do, that we can run this model, right? This is mostly Keras predict model, and P zeros is that I want to predict in the starting, because we have not initialized anything. So hence I'm creating this. I mean, I'm using this model and I'm just predicting on some blank value, just so that at the starting I don't have any problem. And then I'm calling the main function, right? And the main function will start this. We'll call this function, and everything will start working on its place. So let me just go ahead and do that. But let me just use this hand model. I'm not sure if maybe I think it must be corrupt or something. So yeah, let me just do that. So we have got, I mean, so what I'm doing, trying to do is I'm loading the model that we used and that we trained upon, right? And then we have a keras predict function. We have this overlay function that is the basis of what we this is what we use to overlay on top of each other, right? Different images. And if we run the main function, I think that this should work if everything goes correctly. So yeah, if you can see, so let's say if I go for this, you can see that it is predicting correctly, right? So if you can see that, yeah. So yeah, if you can see, so yeah, so that was, I think, about it. And I hope you enjoyed this. If you want to contribute, you can always reach out to me on my GitHub account and let me know if I could clear any of your doubts.
All right, that was very great. I mean, literally, I learned a lot myself, and I hope you guys also um, learned from what Akshay has built. So I'll hand over to Fabio to answer any questions or to give him some time to speak.
Okay, so we don't have that much time. I try to answer as much as questions as possible. I think I answered a lot of them in the chat and in the Q&A section. Just before going to the Q&A, just one quick announcement, and a very important announcement. You've been talking about like starting with deep learning and how to start, which course to take and stuff. And there are a lot of great courses out there. But I want to announce that Akshay and I will be creating a deep learning course with DeepCognition that will be released very soon. And this course will take you from nothing into be able to run and understand all of that Akshay just show you, and like how to use Keras, how to use deep learning, how to use the deep learning studio, the deep learning platform, and all of that. So uh, make sure to follow Deep Cognition's LinkedIn page and Twitter, because we're going to be announcing the release for the course very soon. And if you have any suggestions, something you really want to see, please let us know. It will focus a lot on deep learning and computer vision, Keras, and how to use Deep Learning Studio. All right. Um, so um, just another quick announcement. This will be recorded. This is being recorded. So just make sure to go to the Deep Learning Decognition's webpage after this webinar. Maybe today, later, or tomorrow, you'll be having this recording for you. And so Akshay, I think the only questions is important here. I don't know how to answer right now. Is what's the limit for 3D pooling for your application?
So I think mostly what I try to do is that I have a very hit and try approach. So basically, what I do is I try a bunch of different max pooling layers. So there's not just max pooling; you can all even go for average pooling, right? But max pooling gives much better results. So if you are learning and if you want to explore more aspects, then I would say that you can try as many different pooling layers as possible. So for this, because I was using a 50 by 50 image, and I went for max pooling for I mean for the kernel size of 2 by 2, That means every time my image will be divided by 2. So let's say in the first iteration was 50 by 50, then after one second layer will be 25 by 25, then 12, then 6. Then finally, you will get nothing out of the image. So it should probably stop somewhere in the middle. So I stopped at around 12 by 12. So maybe you should go for, I think, when the image is one fourth of the original one, then you should probably stop.
Okay. And the other one was, is the 2D image flattened to 1D or staged as a 2D as a batch?
No, so what I've done is that when I convert it to CSV file, right? So the entire row is a 50 by 50 into 50 vector. That is, each 2500 pixels are stored in the first row. That gives me the first example, right? But Keras takes images as in terms of 3 dimension. That is, it should have height, width, and the number of channels. So you can always use a reshape, and fill or reshape function to reshape your image when you want to reshape that into, let's say, 50 by 50 to 2500. You can do that, or 2500 to 50 by 50. You can do that. So yeah, it depends on your approach.
Okay. So I think that's all the time we have. It was an amazing session, Akshay. Thank you very much for
Yeah,
Yeah.
for teaching us all of that, because I know people loved it. This video won't be on YouTube. It will be on on DeepCognition's webpage. So make sure to just go to the webpage and see the recorded session there.
so for the people who have registered, what I will be doing, I will be emailing them the recorded video. For the people who have not registered for this session, they have to go to the web page and we will be making that announcement. One thing I want to request to everybody is, once you receive this video, please make sure that you share with your friends and colleagues, because we want to make sure that what you learned today with Akshay, everybody get a chance to hear him and learn about computer vision from him. So it was a great session, Akshay, and I really thank you to spend time today and sharing your knowledge with everybody. And hopefully we'll bring more of these kind of webinars where we can bring more hands-on training and hands-on projects and problems that we can solve in front of everybody, so that everybody get a chance to learn. And as Fabio said, we are looking forward for this course that Akshay and Fabio is going to build. And definitely I will be one of the student myself. And thanks again for joining everybody, and catch up with you next time. Thank
Yeah,
you, Akshay.
definitely.
Okay.
Thank you, Fabio.
Thank
Thank
you
you.
guys.
All
Bye
right.
bye.
See you.
Okay, bye.
Bye.